Hello, in this video we're going to be looking at Ohm's law. Here we go, and essentially Ohm's law is to do with voltage, current and resistance. And at the moment we will concentrate just on a pure resistor here, some current flowing through it, steady current. So in this case we will use capital I for current, and that will produce a voltage V in this direction. So if you like, there's the positive end of the resistor. Now we can think of Ohm's law with a water analogy. So we could think of some water. Okay, it's all there in the tank. Possibly it comes down here and gets constricted in some way, like so. The water drops out here. So what we have here is some water pressure. Okay, so we could think of that as the voltage, because voltage essentially is a pressure. It's a pressure of charged particles, or an accumulation of charged particles. We have a flow down here. Okay, that can be analogous to current. So there's a flow of water molecules that essentially electrical current is a flow of electrons. And here in this area we have a constriction because it's much narrower than at the top here, so that's analogous to resistance. Okay, hopefully that's a useful way to perceive voltage, currents and resistance. Okay, let me draw the sketch again here. So we have our resistor here. That's the European variety of resistor. The American symbol is this one, but they're both interchangeable. Okay, so we have our resistance, we have our current here, and we have the voltage across the resistor there. Okay, now basically Ohm's law can be written, Ohm's law is written as V, voltage, equals current times resistance. Okay, and from this we can therefore say, if we transpose things a little bit, V over I, so in other words divide both sides by I, in other words you don't change anything, V over I equals R. Or we could divide both sides of this thing at the top here by R, and we end up with V over R equals I. Okay, so you have three expressions for Ohm's law. So you can find voltage, the top one here. You can find resistance with this one on the bottom left, or you could find current with this one here. Okay, what about power dissipated? Power dissipated in the resistor. Okay, so essentially the power dissipated, call it P, it's just going to be the voltage times the current. Okay, we know that voltage is given by this thing here at the top. So why don't we replace V here with what we have up here? Let's see what we get. Therefore, power equals, I'm going to put it in brackets, shall we? V, which is IR, times this I here, And that looks very much like IRI, which is the same as IIR, so that's I squared R. Okay. Another thing that we could do is to say, why not replace I with what we know it to be up here? So I is V over R. So then we could also write, therefore, power equals V times, and let's put that in brackets, V over R. That looks very much like V squared over R. Okay, so just to summarize then for Ohm's law, these 6 expressions are going to be really useful for you. Okay, V equals IR as 1, R equals V over I. Okay, I equals V over R, just copying all these expressions at the top here. And then in terms of power, we've got power can be expressed as V times I. Could also be expressed as power equals I squared R. And finally, power can be expressed as V squared over R. So this is fundamental but extremely useful in many units that you study on whichever program you're doing now or in the future. Okay, hopefully that's been useful, and speak to you in the next video. Bye.